All right, so we set up the basic Flask application. I think it's time we start working with MySQL. So first thing we need to do is install pip install PyMySQL. And it says I already have it. Obviously, you would need to install it if you didn't. So we now have MySQL, or at least the ability to connect to it, installed. So we need to set it up. I'm going to be referencing the file that they gave to us, but instead of just copy and pasting it and saying good luck, I'm going to go through it line by line so you understand what's happening. Okay? I'm not going to do a direct copy. I'm going to write it in the moment and explain what's happening as I write it. Okay? So inside of our main folder, I'll just name it the same thing. So MySQL connection.py. There we have it. Now, the first thing we want to do is import PyMySQL. So import PyMySQL. Now we're going to actually import a particular portion of it called cursors. Okay. Think of a cursor as you would on a terminal. It's that blinking box waiting for you to make commands. Think of that while we go through this, and everything might make more sense. So we've imported the cursors. Now we need to define a class called, I'll just name it the same thing, MySQL connection, just like that. Now we need to define the initializer init, just like that. We're going to do a self, and then we're going to do the database name. Okay. And that comes into play later when we have to export it, or whenever we want to use it, we can specify the database in question. That also makes this file modular, and that'll make more sense later. So we need to make a class variable, or I wouldn't say that. I guess it is technically a class variable. We're going to do self.connection. Okay, so we're defining a new variable called connection, and we're going to, every time MySQL connection is ran, this class, or whenever it's returned from the function we're going to declare later, it will open a new connection. So that's what we're doing. Whenever you log into MySQL, you're presented with this screen. If I were to edit connection, you can see that I have a host name, a username, and a password, which is also root. So we have localhost, root, and then root. Okay? We're going to use that information, or it's going to be whatever yours is, obviously, to connect to the database. So self.connection equals connect, or PyMySQL.connect. That is a function that is on the PyMySQL object. And inside of it, we declare everything we need in order to actually get into this database. We need it to have permission. So we need to give it the credentials, right? So the host name is going to be localhost, because that's what it was, remember? If you had a website, this is where you would put the URL that the database would be stored on, so it knows where to go to. Same thing with the next couple parameters, which may be different for each person, which we have user equals root, because that's what it was. Password equals root, because that's also what it was. DB equals the DB that we had that's coming in. So no parentheses there, just the DB that's coming in. That makes this modular. Okay. If we had multiple databases on this particular connection, you'd be able to change it at a moment's notice if necessary. Now I'm going to put in the character set. They specified it, so I'm just going to put it in like that. UTF-8MB4. That sounds so fun. Now, the next part, the cursor class. What the cursor class is this is how you want your connections to the SQL server to return your data in. Do you want it in a dictionary? Do you want it in a list? Do you want it in tuples? Dictionary is one of the better options because, key value pairs. So PyMySQL, okay, dot cursors dot dictionary cursor, DICT cursor. That's what we want. And we're going to X the function call because we're not trying to call it. We're trying to reference it. Okay. And then the last thing we want is auto commit to equal false. The reason why is auto commit will attempt to fulfill your queries before you have a chance to check it. We want the ability to check data before we just let it go through. If you have a really nice modular system that can route things very well, maybe that would be a good option to keep true. We do not want it true. We want to check a few things and make sure our queries contain certain keywords so that we do the correct functions in the order they need to be to get the data or post it, so to speak. So I'm going to auto format, and I'm just going to, there we go. So everything is set up now. This is all good. Everything's set up. There's another look at it if you need to check that out. Now, let's go ahead and define making a query. So defining query the database, right? We're expecting self because of, class function. And then we need a query. Now we're going to specify it as a string. That's what that is. We're specifying that this can only come in as a string. If a query was a number, that would cause an error. So we want to guarantee that it comes through as a string, otherwise it's an error. Data is going to be of type dictionary with a default of none, meaning that if 1 is not specified, that value will equal none instead of an error, which is good. So now this next part is where some people get very confused. They're using things like with statements and then try excepts and finallys and then a whole bunch of stuff that we were never taught. The first thing we need to do is with self.connection, which is what we declared up here, okay, .cursor. So where did we get .cursor from? When we assigned self.connection to MySQL.connect, it gives us a cursor method to run. That is what it's assigning us. So we now have access to it on our connection that we declared up here. Now, what is a cursor? I said earlier that it's like a blinking cursor on a terminal awaiting an order. That's essentially what it is. Now I'm going to rename this as cursor. That's what as means, because I don't want to write self.connection.cursor every time I want to refer to the cursor. So with this being this, we're now going to start looking into error handling. So we want to try some code, right? And if it doesn't work out, we want to catch the exception, right? The exception of what happens. Exception is the type that we're going to be looking for, some type of exception, as E, meaning error. So I'll just write error. All right. Now, if there is an error in the try area, this will catch it instead of breaking the application. If you had an absolute application ending bug in the try area, it will, instead of breaking the application, it will just go to the except statement and give us the error. So that's what we're going to do here. We're going to print error and then the error in question. That is what the except statement is doing. Now, the reason it's red is because the try statement doesn't have anything. If I did pass, we would see that this is correct. So whatever we put inside of the try statement needs to be run. If it fails, the except statement will run instead, okay? Instead of breaking the application. So we need to define the query first. The query is separated. We have the query, which is a raw string with variables that need to be assigned to it. And then we have the data, the variables in question. We need to merge them so we have a raw string with the correct data to send to MySQL. So let's define that here. We're going to attempt the query with our cursor, this cursor, which is this, okay? This is this, and that's what we're defining here, cursor. And the function in question is called mogrify. Okay, what that does is it returns the exact string that would be used in the execute method. It's combining the data. It takes a query and then data. So mogrify the query and then the data, which needs to be a dictionary, and it is. So we're going to merge these two, and it's going to return it as just a raw string. So instead of it saying something like select all from dogs where ID equals %, parenthesis ID, parenthesis S, it will actually say the number that we sent through in data. So that's good. We want this to be a string instead of something that needs to be calculated. So that's what that does. So we've officially gotten the query. If this doesn't fail, then the except statement will never run. We can move forward. So The next thing we want to do is execute the query. So on the same cursor, right, we want to execute this query, and it autofilled it. That's good. What that means is it doesn't mean what it says. Not directly, not the way we think of it. Executing doesn't mean hitting enter. It means, think of this, cursor.paste, right? If you were to paste data into a terminal, you would have a command ready, but it's not ran. That is what's happening here. Execute is like pasting, okay? It's not actually hitting enter. So just remember that. Now, the next thing we want to do, because it's sitting in the query, is we want to find out if this particular query needs to be committed, meaning if we're doing a post request, right? We're adding data to the database or we're updating data. That needs to be committed. That's like hitting enter, okay? That's committing it to the system. That's adding data, okay? There's other stuff that also is like hitting the enter button, but this particular case, we need to check if there's an insert in the query, right? So we're going to do a if query dot lower. That guarantees that even if you write all caps or one cap or no caps, we're always going to have lowercase query. That's fine. SQL doesn't care. Dot find. What we put in dot find is what it's going to look for. What it's going to do is dot find returns the index that it finds this particular word or letter or number in a string. And what we want to find is insert as lowercase, because that's what we're doing. We're converting it to lowercase, and then we're trying to find the word insert. If I say is greater than or equal to 0, that means if it finds the word insert in the query anywhere from index 0 onward, it's good. If it does not find the query, it returns -1, meaning this will not run. So we're going to go inside the insert, and then we're going to commit. So self.connection.commit. What that means is that if we have an insert, right, we're trying to add data to the database, we need to commit it to the system. That's what that function does. It allows us to actually add data. So if we find an insert statement, naturally we want to add. And if it's greater than or equal to 0, meaning it found the word insert, it's going to commit. That's what we want. However, what if we have a select statement? Well, we're going to do an else if, right? Query.lower, just like before, dot find, and we're going to look for select. And once again, is greater than or equal to 0, meaning it found the word select in there somewhere. Well, we want to return cursor dot fetch all. That's going to grab everything it can find in a select statement. It's saying on the cursor object, I want you to fetch everything you can find in the select statement that I specified. Okay? That's what's happening there. Now you're probably wondering, how come this is cursor.fetchAll, but this is self.connection.commit? Didn't we define this as cursor? No, we didn't. Self.connection has multiple methods that are assigned to it from up here. One of them is cursor, one of them is commit. They are adjacent, not inside one of another. So we have to do self.connection dot, and then whatever we want to call, in this case, commit for committing queries, and the cursor for, accessing the cursor object. And that's what we're doing down here. This would be the same as self.connection.cursor.fetchAll. Okay, we're just shortening it because we did up here. So cursor.fetchAll is when we want to grab something from the cursor. Okay, connection.commit means that we actually want to commit it, if that makes sense. So we need one more else, because what if we have a delete statement, right? That's a commit thing. So should I add that up here? Like say if it finds this, or we could, or we can just do a catch-all, because these are the only two that are really unique. So we can do an else, right? Self.connection.commit. Just like that. This will commit anything else, deletes, updates, stuff like that. Really, we can just do an if it's select and then everything else is a commit. But there's something we can do with insert statements for getting data right away. And I'll explain what that is in a second. So this is a good amount of logic to work with, right? We're grabbing the query, we're merging the data using Mogrify, right? Now we have the raw string. We can work with the raw string. So we're going to execute the query. We're going to paste it into that cursor on the terminal, waiting for execution. We're going to do some checks. We're going to check the lowercase query to find the word insert. If we find it, we know we have to commit the data. So we commit it. However, if we find the word select, we're going to fetch all because we're trying to grab data. We're not trying to post it. We're not trying to commit it. We're trying to grab it, right? Or if we find anything else, update, delete, it's going to be committed, right? And if any of this fails, we're going to accept, instead of breaking the application, an exception as error, and we're going to print that error and find out what happened. So why did we separate this from this? Couldn't we combine them? Yes, but there's something else we can do. If we insert new data, what if we want to use that newly posted data and its ID? Well, we would want to return that ID, and they have a function built in for that. Cursor dot last row ID, because would that not be what it is? We just posted a new row. It's going to be at the end, the last known ID, by committing it and then returning that last row ID. And it's not just the ID. I think it is just the ID. But you can use that ID to then go back in and then select a single query using that ID and then grab all the data. So it's actually good to separate these two because now we have the ability to get that freshly inserted row, right? We can grab the ID. That's good. All right. So there's one thing we need to do to close the connection. We're going to do a finally. Now, the way finallys work is they will run whether this fails or not. And whether this runs or not, it's still going to run this no matter what. And that's important for this particular instance because we need to close the connection. And that's what's happening here. We're closing out the SQL connection. By doing so, all of this pretty much happens in like an instant. So it's impossible for, I wouldn't say it's impossible, but very unlikely that somebody can slither into that connection and do a malicious query when there's really no time to do it. So that is the purpose of this. We always want a close. We want to close the connection in between uses. Otherwise, you're leaving it open. So the last thing we need to do for querying is to define a connection to this particular class. So we're going to define a new function outside of the class. Notice it's not inside, it's next to it. Connect, right, to MySQL. Just like that. And we could probably keep it the same just so it's not confusing. We're going to pass in the database name, and then we're going to return MySQL connection and then the database. I'm going to do a little auto format just so it's nice. And this concludes creating the MySQL connection file, the ability to export, and we're going to go in depth about why this is happening in a little bit. But just know that this is required in order to finish up this file and for future use. But I hope that my explanation of this section really started to click, like why we're doing this, because it took me a bit to research this. I hope that makes sense. And the connection up here, I know there's probably still a few questions, but generally just know cursor blinking on the screen, query executed on the cursor, right? We're going to paste it onto that cursor, get ready to use it, do some checks to find out what's the next step. And once we find it, execute that next step, right? And if any of this fails, right, we have a backup so that the server doesn't break. We have a try, which will try this code. If any of this fails, anything, it's going to go, uh-oh, we have to throw an exception, and it's going to print it instead of breaking the application. And then no matter which one of these run, we finally get to close the connection and make sure that our database stays safe from malicious intent.